Today's lesson is going to cover angles of elevation and angles of depression. So first, let's figure out what an angle of elevation is. It's when you're looking up at an object. So if you notice the picture here, we have someone looking up at a lighthouse. It is formed by two things. It is formed by the observer's line of sight, so where it's going from their eyeballs, looking up, and by a horizontal line. So that's just connecting back to make an angle. So notice where that angle is. It's in between those two objects. And it's when they're looking up at something. Okay, so the description in number 1 is this picture that I was just working with. So Casey sat to the top of an 84 foot tall lighthouse. So let's label that. My lighthouse is 84 feet. At an angle of elevation of 58 degrees. So that angle is going to go in between your diagonal line and your horizontal line. Okay. Casey is 6 feet tall. They want to know how far he is from the base of the lighthouse. So him to the base of the lighthouse, we want to know that distance, x. Okay, well, we are not using Pythagorean anymore, right? We now know what trig is. So you need to write down what SOHCAHTOA stands for. We've got sine, which is opposite of our hypotenuse, cosine, which is adjacent of our hypotenuse, and tangent, which is opposite of our adjacent. Alright, so looking at my picture, there's a couple more things I need to figure out before I can go. My triangle is this in yellow, and I only know one of my sides so far. I know, I don't know any of my sides. I know what I want to find. I want to find this x value. But I don't know one of the sides I need to know. I either need to know the line of sight, or I need to know that height. Well, I can find the height, because I just need this amount of it, and I need to find that by taking Casey away from the lighthouse. So if I do 84 minus 6, I'm going to get the height of the lighthouse, taking Casey out of the equation. So just be careful if it's not on the ground that you're looking to take out what you need to take out. So again, you are always in acute angle. So I am 58 right now, and I need to label my sides accordingly. I'm standing at 58. 78 is opposite of me, and x is next to me, so adjacent. So 58 is not touching me, it's across the table from me. X is touching me, it's one of the legs that's touching me, so it would be adjacent. If I scan SOHCAHTOA, I'm looking for opposite and adjacent, which is in TOA. So I'm going to use tangent. Tangent of your angle. Your angle is always with your trig work. Tangent of angle is equal to opposite, which is going to be 78, over adjacent, which is going to just be my x. So remember, when x is on the bottom, this is a two-step problem. Put it over 1 cross multiply, so 78, and then I get x tangent of 58, and I cross multiply the other side. So I need to divide by my tangent of 58 on both sides, and I'm going to get x is 48.7 feet. So Casey is 48.7 feet from the base of the lighthouse, if you were to write this. Okay, let's look at number 4. A dog is standing 5 feet from the base of a tree. So I have a tree, and then I have a dog. He is standing 5 feet away. Unrealistic 5. Looking up at a cat in the tree. So the dog is looking up at the cat. And the cat is 16 feet in the air. My cat has a height of 16 feet. What is the angle of elevation from the point the dog is standing at on the ground to the cat? So where my dog is looking up. So again, that's formed by my diagonal line of sight for my dog, which is my red one, and my horizontal line, which is my blue. So I want to know this right here. Okay, well, in order to do that, I'm going to have to use my inverse, which is So labeling my sides based off of what I am. So I'm standing at the arc, or sorry, the angle, which is going to be here. And if I label 16 is opposite of me, right? It's across from me. And 5 is next to me and is adjacent. So again, I'm dealing with O and A, which if we have our separate already. O and A is again tangent. So I am looking to use my tangent function. Since it's the angle, we're going to use the inverse. So tan inverse of opposite, which is 16, over adjacent, which is 5. Type that in, make sure you push second tan, and you're going to get the angle to be 72.6 degrees for that angle of elevation from the dog to the cat. Okay, let's turn to page 10, and let's look at what an angle of depression is. So angle of depression is when we're looking down at an object. The angle of depression is formed by the observer's line of sight. So we saw that before. It's always a diagonal line. And a horizontal line. So your horizontal line and the observer's line of sight. Now it's important. Here we go. It says that angle of depression is congruent to the angle of elevation because they are alternate interior angles. So all of my angle of depression problems are going to be transformed into angle of elevation problems. And it's really like not doing anything different than we just went over. So looking here at this image, it's the description down below. But what they're talking about is that this horizontal line and the one above in pink are alternate interior if I look at that blue transversal. So my angle of depression sits right here between those two. Well, it also can be right here between these two as an angle of elevation, which is what we're going to do for these problems. So we're going to kind of switch the wording. So a lifeguard is sitting on a platform looking down at a swimmer in the water. I can change that to say a swimmer in the water is looking up at a lifeguard in the platform. So now I'm at an angle of elevation. If the lifeguard's line of sight is 8 feet above the ground, so what that's telling me is that my lifeguard is 8 feet up here, and the angle of depression to the swimmer is 18. Well, I can transform that to say that the angle of elevation to the lifeguard is 18. These are congruent. So I have an 18 here. They also would have an 18 out here into their angles. They want to know how far away is the swimmer from the lifeguard. So how far does he have to swim in order to get to the lifeguard chair? So again, if we need, and I am looking for which one I am. Now you're standing at 18. So 8 is opposite of you. It's across from you. And X is next to me, so it's adjacent. So again, you're looking at Ella, which is really common in these problems. Don't assume it always happens, but it is very common. So I'm going to set that up. So tangent of my angle, 18, is equal to opposite, which is 8, over adjacent, which is X. Again, this is going to be a 2-part problem. Put it over 1. 8 times 1 is 8. Tangent of 18 times X is X. Tangent of 18. So I'm going to need to divide by my tangent of 18. And I am going to get X is 24.6. So he has to swim 24.6 more feet in order to get to the lake. Okay, so I'm looking at number 6. A pilot is in a helicopter and he's got to landing pad. So I have my helicopter and I have my landing pad. The angle of depression is 73 feet and the horizontal distance to the pad is 73 degrees. It's 1,200 feet. What is the altitude? So altitude means height. So they want to know how high up the helicopter is. I know my helicopter to my landing pad horizontal distance is 100. And so we just need to complete our right triangle. Now again, it says if the angle of depression is 73 degrees. So helicopter looking down at landing pad is 73 degrees. If I reverse that wording, I'm going to say landing pad looking up at the helicopter is 73 degrees. So landing pad looking up is going to sit right here. Now the original one for an angle compression always would be horizontal line, so it would be right here. But these are congruent because they're alternate interior angles, so I can put it down and over that transversal. It always needs to be horizontal to diagonal line. That's never vertical to diagonal. That is the wrong place. So I'm looking at my sides, and I have 73 is who I am, so x is opposite of me, and 1200 is adjacent to me. So again, I'm tangent. I'm going to say tangent of 73 is equal to x is opposite over adjacent, which is 1200. So this is just a single step. Now, x equals x. Tangent of 73 equals 1200 is 1200. Tangent of 73. So when I type that into my calculator, I am going to get x is 300 for every 1,925 meters. So that's how high up my helicopter is. All right, you go ahead and pause the video and try number 8 on your own and answer it when you are asked. Please bring any questions